We have made it to our first practice video of the Data Structures and Algorithms series. And because it's our first one, I want to take a moment to discuss how these practice videos are formatted and how you should use them. So in all the practice videos, be it an algorithm practice or a coding practice, I'll present you a problem and kind of flesh that problem out. And then I will give you a chance to pause the video. I'll tell you when to pause the video, and I would expect that you pause the video and you then work out the problem. And you work it out till you get to the solution, or the best solution you can come up with. And then you resume the video and you walk through your solution along with my solution and you kind of compare the differences. Now, one temptation that students have is just to go straight to the solution, look at the solution, and move on because it will save a lot of time. And although you might convince yourself that you're understanding the solution that you're seeing, you're not truly gaining a deep understanding of the material. You might in some cases, but most of the time it turns out that you really don't truly get it till you get your hands dirty and you really get into the problem. So try to resist the temptation of jumping right to the solution. Now, if you can't get to the solution and you're in one of my classes, feel free to reach out on our discussion forums and I can help you work with you through the solution before you look at it. Or if you're just looking at these videos outside of my courses, then take a look at the solution, see kind of what you did wrong, but go back to your solution, try to get it to work, or try to understand where it fell apart. So that's how these practice videos are going to run. The problem I have for you in this practice video is finding the median. So I want you to write an algorithm that will find the median value of a list of numbers. Just as a refresher, the median value is the middle number of a sorted list of numbers. Okay, so pause your video now and try to develop an algorithm that will uh, correctly identify the median value of a list of numbers. So what you should really be focusing on is what are the inputs, what are the outputs, what assumptions, what are some of the base cases, what are the different scenarios that might arise based on the input that we're getting. So identify all those things and then identify the various steps that you need to actually compute the median. Once you write that out in a more natural language based algorithm or a flowchart, then resume the video and we're going to go over the solution. As you've heard me say before, and as you will hear me say many more times, starting out on paper is the best way to start with a problem. So let's give us an example of numbers that we might want to work through. So say the list is 1, 5, 4, 7, 3. So the first thing that we'll see here is it's unsorted, and we're trying to figure out what's the median number in the list. So we know that the median number is the middle element of a sorted list. So the first thing we want to do is sort this list so we can find that middle element. So we know that we have 1, the next one would be 3, then 4, then 5, and then 7. So what's the middle element? Well, we get rid of 1, we get 7, get rid of 3, get rid of 5. The middle element is 4. So we know that for this list here, it was 4 is the median element. Okay, good. So that was one example. We'll come back to that in a second. Let's go back to another example here where I maybe start with 7, 8, 2, 1. So now, again, let's sort these. So we put 1 first, then 2, and then we need 7, and then we need 8. So now we want to find the middle element, but there is no middle element because we have an even number of numbers in the list. So what do we do to find that is we take the average of 2 and 7, and we know that the average is just simply 7 plus 2 divided by 2. So good. We know we have two cases now. We have two base cases that we have to consider. We have to consider if there's an even number in elements or if there's an odd number of elements. Okay? So we've identified that just by working things out on paper. The other thing that we might want to consider is what happens if the list is empty? If the list is empty, what should we do? Well, if we know that all the numbers have to be positive, then maybe we can just send 0 back. But if the numbers don't have to be positive, then sending 0 back might misrepresent what the median actually is. So it gets a little bit more tricky, and it comes down to the application that we might be doing. Maybe we can throw an error, maybe we can throw some type of message, or maybe we know that we're never going to get an empty list. And so when we go to understand the problem a little bit more formally in the next slide, we'll talk about that a little further. But the key thing that we did here is we wrote out a couple examples of possible input, right? The 15473 and the 7821. And we realized that there was two cases that we have to worry about. What happens if the list was even, the list is odd? We also have a basic game plan here. We know that, hey, we want to take the list, and before we do anything, let's sort it. Once we sort it, let's figure out, is it even or is it odd? And based on that, we're going to compute the median slightly differently. So now that we've kind of scratched things out, kind of worked through it a little bit, now let's go into getting a more formalized and deeper understanding of the problem. Now that we worked through this problem on paper and we kind of got a sense of the problem as a whole, what the inputs are, the outputs are, what maybe some of the steps are going to be, let's kind of reevaluate our understanding of the problem. So what are the base cases that we want to consider? Well, what happens if the user gives us an empty list as input? What happens if we have a list with an odd number of elements? What happens if we have a list with an even number of elements? We treat each of these slightly differently. So we want to make sure that whatever algorithm we create, given the inputs and the outputs, that we can handle these base cases. So let's figure out what our inputs are going to be. Well, let's say that our inputs can be a list of n unsorted numbers where n is greater than 0. So let's take our inputs that we've decided on. We're making an assumption where we have at least one element in the list based on this where n is greater than 0. So if we go back and look at our base cases, we see that the empty list is no longer an option because of our assumption of n greater than 0. So when we develop our steps to our algorithm, we don't have to worry about the empty list case. We've checked that one off. Now that might be a limiting assumption where we do need to handle empty list, and so then we would have to change our inputs. But for now, let's assume we don't have to worry about empty list and we'll move forward. So now what are our outputs? Well, our output is MED, or a variable that denotes the median of L, which is what we would expect from all the understanding that we've already been through in terms of our scratch work. So now that we have a good understanding of the problem, we've worked through the problem on paper, now we can start formalizing the steps. Now before I show you my solution, and I'll actually show you a solution as a more natural language pseudocode version and a flowchart version, I want to make the point that just because your solution looks different than mine doesn't mean your solution is wrong. There's a lot of different ways that we can solve these problems that we're going to have, and you just want to make sure, especially when we're just talking about the characteristics of an algorithm, you want to make sure that your algorithm is unambiguous. It's clear. It solves the problems. All those checkpoints that we talked about. If your algorithm hits all those, then it's a good algorithm, right? Even though it might not be the algorithm I came up with, doesn't mean it's a bad algorithm in terms of its characteristics. Okay? So here's the algorithm that I came up with. On the left, you see the more pseudocode version, and on the right, you see the flowchart version. They're solving the same problem in the same way. They're just displayed in different manners. So the first step is we know that we're getting an unsorted list. And with the unsorted list, we have to get it in sorted order because we need to find that middle element. And trying to find the middle element without sorting it first is very difficult. So I'm going to call this function called sort. Now, once you get a little bit more advanced, you're going to learn a whole bunch of different sorting algorithms. And so you might want to specify what sorting algorithm you're going to use. But for right now, we're just going to sort from min to max. And then after that, we want to check to see if the list is an odd number of elements or an even number of elements, because we know from our scratch work that we're going to have to treat them differently, right? So if the element or if the length of the list is odd, we just simply find that middle element. And from your intro classes, you might be looking at this L at n over 2 part of the code going, oh, that's integer division. If you wanted to be a little bit more explicit and not assume that the person reading your algorithm would understand integer division or guess that it's integer division, You could put the floor symbol in there, so you take the floor of that. But since I'm accessing it like I would access an array, any programmer reading this would look at it as integer division. So it's okay to have it in this style. So we take the middle element, and then that's our median. However, if it's false, meaning it's not odd and it's actually even, we have to take the average of the integer division n over 2 and n over 2 minus 1. And again, we go back to our scratch work for all the reasons why we figured out those numbers. Now, the other thing I want to point out is we also use the function average. Now, average, we don't really need to worry about explaining because average is pretty straightforward. Anybody looking at your code is going to know what the average of two numbers is. You add them together, divide by 2, there's your average. So again, that would be a floating point number. So if you were implementing this solution, you would then probably make med or median, the variable there, a double or a float if you're implementing in C++, because you know you're handling the average. And you wouldn't be worrying about integer division there. So here are the algorithms that, or here's the algorithm that I came up in both the flowchart form and the pseudocode or more natural language form. So I hope this clarifies the algorithm design process a little bit for you. If not, there's going to be some more code practices or algorithm practice problems coming along the way.